Amine molecules are bases, and because of this, they react with water, and they also react with strong acids. In this video, I'm going to give you 3 examples of amines in acid-base reactions. In the first reaction here, I am showing an amine reacting with water. I want to start by saying that the structure of this amine could be anything. I'm showing a primary amine, but it doesn't have to be a primary amine. It could have all hydrogens on it, it could be a secondary amine, it could be a tertiary amine. In this reaction, the water molecule is going to split into 2 pieces. One of the hydrogen atoms from the water molecule is going to be added to the nitrogen of the amine. So the amine is now going to have 4 bonds. It's no longer considered an amine when it has 4 bonds. The rest of the water molecule, an oxygen and a hydrogen, they're just going to be left alone. The oxygen and the hydrogen have a negative charge on them. That's the hydroxide ion. And when the nitrogen gets its 4th bond, it gets a positive charge on it as well. So this is an ionic compound. This is a version of an ammonium ion. It's not ammonium, but it's like a version of an ammonium ion, and this is hydroxide. When we have an amine reacting with hydrochloric acid, the reaction is very similar. The hydrochloric acid is going to split into 2 parts, just like the water molecule does. The hydrogen atom is going to add itself to the nitrogen of the amine, just like when we react it with water. And because we've got a 4th bond to that nitrogen, it's now going to have a positive charge. The other product of this reaction is the other half of the HCl molecule, so this would be a chloride ion. You can use any one of similar strong acids in this reaction, so you could be doing this reaction with HBr, or you could be doing this reaction with HI. If you were using a different acid, so for example HBr, this product would be exactly the same, but over here you'd have a bromide ion instead of a chloride ion, or if you were using HI, you'd have over here an iodide ion. This reaction right here is used quite a bit in the pharmaceutical industry to make over-the-counter and prescription pharmaceuticals a little bit more consumer-friendly. Here is a very specific example of reacting an amine with hydrochloric acid. This molecule right here is ephedrine. It is a molecule that has kind of a funky smell to it, and it's not water-soluble, but when we react it with this hydrochloric acid molecule, and it's just doing this very predictable reaction. So the only part of this molecule that is being altered is the nitrogen atom. All the rest of the molecule is staying exactly the same. The nitrogen atom is having an extra hydrogen put onto it from the HCl. So the extra hydrogen from the HCl is going to go right here. And then because we've added a 4th bond to the nitrogen, it's positive charge. The other product of this is Cl-. So again, I said this is the ephedrine molecule. The product of this reaction we call ephedrine HCl. And this is a molecule that is sold under the brand name Sudafed. So it's a great decongestant, nasal decongestant. It is much more preferable than straight ephedrine because it doesn't have a funky smell. Ephedrine has a funky smell. This has no smell. It doesn't respond quite as well in the body as straight ephedrine does, but it responds well enough. And if you take a look in your medicine cabinet, particularly if you're looking at cold medicines and things like that, you'll notice that a lot of the molecules, a lot of the active ingredients are followed by HCl or HBr. Things like that. And that tells you that that molecule is an amine that has been reacted with HCl or HBr to just make it more consumer friendly.